Welcome everyone. Here is a question from GATE 2022 Life Sciences. The question says, a newly identified viral protein contains one long alpha helix spanning 60 amino acid residues. The number of main chain hydrogen bonds formed in this helix, and we need to figure out the number. As we all know, alpha helix is a common structural arrangement in the secondary structure of protein. And alpha helix involves the intrachain hydrogen bond formation between the carboxyl group of the peptide bond and the NH group of the peptide bond. So if you look at the arrangement of the peptide bond, we have NH, C alpha, CO, then again NH, C alpha, CO. So we'll just consider the two amino acid residue. And what it has been asked in the question is the number of main chain hydrogen bonds. That means the hydrogen bonds coming from the polypeptide backbone atom, which is CO, NH. So let's try to understand the pattern of hydrogen bond formation in the alpha helix. So in the helix, the CO group of residue I forms a hydrogen bond with the NH group of residue I plus 4. What does that mean? So here we can give the numbers to these amino acid residues 1, 2, 3, 4, 5, and 6. You can even give the other nomenclature, like you can count one as a I and then second amino acid residues as the I plus 1 and so on and so forth. So what is given here is that the CO group of the residue I, it forms a hydrogen bond with the NH group of residue I plus 4. So the first will form a hydrogen bond with a fifth amino acid residue located downstream. Same, the second will form with a 4 amino acid residues located away from it. That means the second will form with the sixth. So the CO group of the second amino acid residue will form a hydrogen bond with a NH group of the sixth amino acid residue. As you might be aware, for a hydrogen bond to form, you will be requiring a hydrogen bond donor, and the donor here is NH group, and then you need to have hydrogen bond acceptor. So hydrogen bond acceptor is going to be here as CO. But you need to understand something important here, and the concept is the total number of amino acid residue here is 6. And if you all can observe it carefully, remember the first CO is involved with the fifth amino acid residue in the formation of the hydrogen bonds, second with the sixth one. However, for the third amino acid residue, there is no potential hydrogen bonding partner. Similarly, for the fourth one, fifth one, as well as the sixth one. The reason being, this peptide is only 6 amino acid long. So how many hydrogen bonds are getting formed in this hexapeptide? And the answer is 2, because the remaining amino acids at the terminal, that means the residue number 3, 4, 5, and 6, the CO group of these amino acids don't have the potential hydrogen bonding partner. Similarly, we can read this hydrogen bonding pattern in a different way. You can consider the NH group of the residue I. In that case, we can say the NH group of residue I forms a hydrogen bond with the CO group of residue I minus 4. So for example, I can again give the numbers to these amino acids 1, 2, 3, 4, 5, 6. It's a hexapeptide. So the NH group of residue I has to form a hydrogen bond with the CO group, which is a hydrogen bond acceptor located upstream. That means I minus 4. However, there are no potential hydrogen bonding partner. Similarly, for the second residue, third as well as fourth. However, for the fifth amino acid residue, if I am considering it as I, so I minus 4 is going to be first amino acid. So the NH group of this can form a hydrogen bond with a first one. Similarly, the NH group of the sixth amino acid residue can form a hydrogen bond with a second amino acid residue. And that's the reason I'm calling it as INH, forming a hydrogen bond with a ICO located 4 residues earlier, which I'm calling it as a I minus 4. So I to I minus 4. Again, in this case, if you can observe it carefully, the total number of hydrogen bonds present for this hexapeptide is 2 only, because the NH group of the terminal amino acids do not have the potential hydrogen bonding partner. So in this case, the NH group of residue 1, 2, 3, and 4 doesn't have the potential hydrogen bonding partner. Now, with all this, we can come up with a formula that is N minus 4. N is the number of amino acids. And then I'm subtracting with the number 4. The reason being, either I'm considering the CO group of ith amino acid or the NH group of the ith amino acid. In all these cases, the terminal amino acids will not have the potential hydrogen bonding partner. And what is the number of those terminal amino acids? Those are 4. So answering this question, the number of main chain hydrogen bonds formed in this helix is going to be 60 minus 4. And that number is going to be 56. This is a concept-based question. I hope this answer is clear to each and every one of you. If you do have any query, feel free to comment. Thanks for watching the video.